Casually watching a YouTube video on a computer more powerful than anything humans could build decades ago. This progress, and all the sophisticated machinery you take for granted, rests on a foundation of rare and precious materials called dysprosium, neodymium, and tantalum. And the process of getting these rare materials from the ground into your device is ugly. The mining industry contributes to air pollution, water contamination, and the destruction of natural landscapes. Hazardous chemicals like cyanide, sulfuric acid, and chlorine are used to extract these resources, posing risks to workers, local communities, and biodiversity. Rare resources become political tools when nations restrict access to them for other ends. But what if we could replace Earth's mining industry with a clean method harmless to all? Well, we actually can. We just need to look up. Opening music, asteroids are composed of trillions of tons of rock, metal, and ice. They are remnants of the gas clouds that formed the 9 planets 4.5 billion years ago. They can be as small as 1 meter or as large as entire protoplanets the size of countries. Most are concentrated in the asteroid belt and the Kuiper belt, while thousands of asteroids drift between the major planets. As space travel becomes increasingly feasible, scientists and economists have begun focusing on the resources found on these asteroids. Even relatively small metallic asteroids may contain trillions of dollars worth of industrial precious metals like platinum. Larger asteroids such as Psyche 16 could hold enough iron and nickel to meet global demand for millions of years. At current market prices, these rare raw materials alone would be worth trillions of dollars. Well, not literally, but technically speaking. For instance, over 20 million tons of gold exist in seawater, valued at roughly $7.5 trillion. Yet extracting this gold is so costly that selling it would still result in losses. Asteroid mining faces a similar challenge. It remains too expensive to replace terrestrial mining. If accessing resources worth billions requires spending trillions, it simply isn't worth it. What makes asteroid mining so difficult? The principle is actually quite simple. The most basic technical approach involves selecting an asteroid, moving it to an accessible location, then dismantling it into usable products. Unfortunately, all of this collides with fundamental problems humanity has yet to solve. Access to space is prohibitively expensive. Simply reaching low Earth orbit costs thousands of dollars per kilogram of payload in rocket fuel. Accessing higher orbits adds thousands more. Therefore, we need cheaper space travel to make asteroid mining profitable. One solution is replacing traditional rocket engines with electric propulsion systems. We've already used electric propulsion in numerous scientific spacecraft. Theoretically, we only need to build larger electric engines to meet the demand. While electric engines lack the thrust to reach space, once in space, they can travel vast distances using minimal fuel. This means we don't need to spend heavily on fuel just to transport fuel into space. Though this doesn't solve all cost issues, it makes our first mission significantly more feasible. Now that we have an electric asteroid mining spacecraft, the next step is to find a suitable asteroid and bring it back to Earth. We have already successfully visited asteroids with space probes and even collected samples. However, to make our mission simpler and more cost-effective, our first target will likely be a near-Earth asteroid, one orbiting close to Earth. After months of travel, our spacecraft finally reached the asteroid. Its formation was peculiar, dotted with small impact craters, having changed little over billions of years. Our first task is to stabilize the asteroid and stop its rotation. This can be achieved through various methods, such as vaporizing its surface with lasers or using thrusters to halt its spin. Once we successfully stabilize the asteroid, we must wait. Orbital mechanics are complex, but if you push an object in the right direction at the right time, you can move very large objects with relatively little force. So we waited for the optimal moment. Our spacecraft ignited its thrusters, propelling the asteroid into orbit and bringing it closer to the Moon. The Moon is crucial because its gravity helps us transfer the asteroid into a stable Earth orbit, saving significant fuel. This journey itself takes several months.